We have Rudi, an Irish data designer who took the scenic route to a career in visualizing and telling stories with data. He started off with a PhD in bubbles. Okay, you can explain more about this maybe. Worked in electronics schooling, briefly taught Python in Sri Lanka, before working as a data designer at a DOC, Accenture's Global Center for Innovation. Last year, he left to start his own business, data and design, and recently had his work around visualizing Irish housing vacancy exhibited in the Science Gallery in Trinity College in Dublin. And today, he's telling us all about bubbles, I hope, and storytelling with systems.
That's a bonus. That's the bonus.
That's a bonus. Great.
Yeah, thank you very much for the lovely introduction. And like was said, I'm Rudi. I'm a data designer from Ireland. I don't think there's any other Irish people here. If there are, please raise your hand, because I've been looking for you. No more? That's great. And that's opportunity. So this presentation is going to be a little different from the fantastic ones that we saw earlier on today. These are a series of experiments I've been doing around mapping out systems. So these are absolutely not polished, they're absolutely not finished, and they're absolutely going to break in some way. So this entire presentation is actually a Svelte page, and please come to that fantastic unconference that Matthias and Connor are organizing, because at Christmas time I got into their work around Svelte with D3, and it was just fantastic, and it's kind of made me change into that direction. So if you're a kind of a coder, please do come to that later. But what I'm going to be talking about today is actually a passion project of mine, which is around mapping out systems. And I left the consulting world last year to start off my own company in this space. And clients started coming to me with questions that I was like, at the back of my head, I was like, this is actually a problem that systems design or systems thinking could really help with. Now, the clients weren't coming to me in this way, but in the back of my mind, I said, there's probably something there. And, you know, it's quite a broad term, systems. What does it mean? One of my favorite examples of systems thinking is actually in The Wire. So in The Wire, it's full of tragic characters like Stringer Bell or D'Angelo here. And these tragic characters are trying to change the system in which they're operating in some way. For example, and it's probably not spoilers because this came out years ago, but Stringer Bell is trying to legitimize his business and get out of the drug trade. But he's not a great systems thinker. He's not able to see the kind of wider picture that kind of would give him the notion that he might be a little bit naive when it comes to dealing with politicians and might be able to be played. So even though there are these tragic characters in The Wire, there are also some excellent systems thinkers. And I've been really fortunate to have worked some of these in the past. These are people who can navigate organizational complexity. They seem to kind of be able to second guess how the organization is going to respond to things like acquisitions. These are people who can kind of step back and look at that 10,000-foot view, but also dive into the minutiae. So these are some of the most impressive people I've worked with. And I've worked in design studios with people who are actually in as systems designers. This is a little different because that term already has connotations around like integrating different systems together. So I've used the word system, I think, maybe 14 times since I started this presentation. So let me kind of define it for a moment. So Donella Meadows, in her fantastic book, Thinking in Systems, defines a system as an interconnected set of elements that's coherently organized in a way that achieves something. By the way, this book is fantastic. The audiobook is great as well. She finished it, well, she left it unfinished in 1993 and sadly passed away shortly afterwards, and it was finished after her death. But this could have been written yesterday. It was remarkable, the stuff that she was saying in the 70s and the 80s. So this is a very broad definition. So isn't everything a system by this definition? But the last part, the coherently organized, is the key. So let me give you an example of what's not a system. Imagine a big pile of garbage or trash or rubbish, depending if you're from the UK or the States. In that pile, if you take some garbage from that pile, it's still a pile of garbage. The interconnections between the elements might be there. Things might be sitting on top of other things, but they're not organized in a way that's actually achieving something. So that's an example of what isn't a system. And we see real systems all around us in nature. We see ecosystems, but we can also think about, mapping out organizations and things like that. And by extension, systems thinking means finding the relationships between those things and then understanding the resultant behavior after this. So for example, if you're thinking about an organization, it's like, here's the different relationships that are existing, but what's the organizational behavior behind it that this is driving? So far, so good. We've got this kind of way of looking at problems. I think it's a really useful tool for what's called those wicked problems, where you can't really reduce things into separate parts. You've got a whole range of interconnected elements. And yes, my hands are going to be moving all around today. So what's the problem? So you start thinking about the complex process that you want to start mapping out. You say, okay, this is connected to this, and then you start doing a few more, and you start saying to yourself, oh yeah, and these are kind of in the same group, and we'll color this group this way, we'll add these ones onto it, kind of work on it for a few hours, and you kind of go back to your earlier ones, and it's all going pretty well. It's actually getting a lot of things together, and you have it all clear in your head, and then you go to a colleague, or God forbid, a client, and kind of show them, look, we have it done. And they look back at you like you're looking at them like this. So that's the challenge here, is we're trying to map out complex systems. And there's some great software packages out there that let you do that. Kumu, for example, allows you to kind of bring in from Excel a list of nodes and edges and kind of create some visualizations after that. But after experimenting with things like graph theory and Svelte, I thought we could maybe do some more experiments around this area to try and see if we can bring in some of my learnings from data visualization and analytics. And that's what I'm going to be talking about today. It's going to be about my experiments in systems. And the experiments have 4 parts, but I think the main disclaimer, and why I've been saying this compared to other talks, is that this is very much a work in progress. But really what I wanted to see was to see 4 different things. First of all, I wanted to see, could I automatically ingest system maps that other people had created? I don't know if anyone's done this, but manually taking a series of nodes, like was presented earlier for that Nightingale project, and manually putting it into Excel and figuring out what the links between are, like, that's an awful task. I didn't feel like doing that. So I was like, is there a way to kind of do that automatically? Analyzing is the main part and the main differentiator between what I'm talking about and the existing packages out there today. So I'm trying to see, can we ingest a system and use kind of graph-based methods to figure out things, important things for systems like feedback loops or understanding, where we might intervene. We're going to visualize this in hopefully an intuitive way, but probably not. And then finally take action. I don't want to just have lots of floating balls on the screen. I want us to be able to, we want to provide the user with insights around, look, here's how you can actually take action here. So first we're going to start with the system, and it's all coming out a little bit washed on the screen, but that gives you all the more reason to watch this back on YouTube when it goes online later. So you get to watch this twice, even better. But the intention is not to actually look at this system anyway. The main kind of takeaway from this slide is that these things can be complex. I don't think you need to be able to read this to see that it's complex. And this is an existing system map created by the System Mapping Academy. They've got an excellent free toolkit in Miro that kind of just takes you through that step-by-step process of taking a challenging problem and trying to map it out. So for this example, it's looking at the ecological and social consequences of fast fashion. I'll zoom in for a quick second so we can have a look at what I'm talking about here. And actually, the lines aren't even coming up on the screen. But the different things like consumer desire, consumption of new clothes, these are nodes, these are entities. And we've got links between them, red and gray ones. And that denotes whether those relationships are direct or inversely proportional. So do they rise together, or does one rise and one fall? So the first part of my experimentation was around extraction. So can we take this diagram as an input and automatically detect where all those nodes and links are? And the short answer is yes, you actually can. There's a few little tricks I've been using because I used to work in consulting and I used to see how many things were actually put up on Mural and Miro boards. And a lot of stuff, a lot of organizational goodness is actually dying on the vine. You kind of stick it up on Mural, you have a big stakeholder activity, everyone's happy. You might even use 1 or 2 little Post-its from it, and you just leave the rest. So it's kind of a side project of mine that I've used for this in terms of actually extracting stuff out from those Miro and Mural boards. And that's something that if you're happy, if you want to know more, please come and chat to me later. So I won't spend as much time on that. So that's the first step, is extracting. So we've actually been able to pull out kind of a series of connections from that system map. And we also know what direction things are moving. So let's go with some whoosh transitions here. Oh, look at that. That's Svelte, guys. 5:30, unconference. I think it's room 2. If you want to do those swish, come to that. So we've been able to extract out this system. So the first thing we're going to do is actually start exploring it. So again, we can do some pretty standard interactions here. We can start hovering over different nodes for a description. So again, you can see, and the intention here is not for us to go through all of the different nodes, but the point is that this is kind of being done automatically. We've taken in these complicated nodes and links, and we've determined what these groups are. Well, sorry, the groups have names already, but we've determined where these groups lie and the hover over behavior. Next, we can click on a node, obviously. So clicking on this consumer awareness of environmental impact gives us nodes that are traveling into it and nodes that are traveling out of it. The dashed line denotes an inverse relationship. So to use this for example, again, this is a system that was pre-created, and a lot of these exercises are actually good for validating or invalidating the ideas you already have. So I may not necessarily agree with the fact that they're saying that like when emissions goes up, people's awareness of that environmental impact goes up. Like that is a very, like any one of these links is almost a conversation or a system map in itself. And likewise, for the environmental impact, when that goes up, do we actually know more of it or not? But these are really useful as mind model exercises. And finally, we've got that consumer awareness leading to a decrease, because it's a dashed line, in consumer desire. So far so good. We've got hover, we've got click, we've got, it goes whoosh, that's all good. But the main kind of differentiator, the main kind of thing I wanted to try a little bit differently here was if we could automate out some of the processes around systems using graph theory. So what we can do is we can look for closed paths in the system, and what they are loops. Oh, sorry, I also forgot to mention that you can also click on a section and we could hover all those nodes and see the different things within each section. But the next bit is around identifying feedback loops. So feedback loops are kind of a key part to systems, especially when we start thinking about how can we actually make positive change within the system. So I'm going to start with balancing feedback loops. So balancing feedback loops are actually the ones that we want to see. These are the things that we see in nature all the time. And this is what happens when a system acts to restore itself back to its original state. So if we take an ecological system example, we've got wolves and sheep, and if the sheep population grows, then more wolves will also grow, the wolves will eat the sheep, and the sheep population falls back down. So these are seen in nature all the time. The example here, and all of these are kind of automatically detected by the code, so I'm only going to show a few. But in this example, we've got like, you have more clothes, that leads to throwing out more clothes. If we all do that, that means in theory there'll be more second-hand clothes available for us to buy, and we're not going to buy as many new clothes. So again, the more clothes we own is leading to a decrease in those owned clothes. There's a few more feedback loops within this that I won't go into any great detail around the balancing loops. But you can kind of get the message that we've got this effect of a system to kind of decrease that. And these don't have to necessarily be small. This is a larger loop that kind of combines elements of consumer desire, consumption, and environmental impact. So again, we can kind of do this in an automated way where people can have a look at these systems and start thinking about how can we intervene. For balancing loops, we don't necessarily want to intervene. It's quite a natural process. Where we might want to intervene, though, is around reinforcing loops. So reinforcing loops act to amplify the system. So if we perturb the system in a certain way, it gets even bigger. So we see these in kind of exponential growth and decay. The rich get richer, for example. And this loop here is kind of an example of that. As people increase their consumption of new clothes, that leads to more profits, which itself might lead to more marketing, which leads to more desire, which leads to more consumption. This is very common that we've seen all across. So for this example, we've been able to identify there's about 10 or so different reinforcing feedback loops throughout the system. And once we can identify them, we can actually give users the means to actually think about, okay, what are the interventions we can make to try and reduce these things? So you would look at any one of those nodes and say, like, where can we potentially intervene to try and start balancing this? Should we be regulating the marketing of these companies, for example? Or how else can we kind of think about consumer desire? And again, this is not meant to point you in, here's the exact intervention you need to take, but rather it's a way of actually thinking about things in the collective rather than individually. And we've also got some larger reinforcing feedback loops as well. Again, I don't think me reading out all these items is really going to be of benefit to the audience here today. But the key thing is that we can put in a kind of a PDF or a Miro board or a mural board, and we're actually getting out really useful information about some of the loops within that system. So that's the first part. We're talking about making interventions, that we can identify the loops that are within this, and we can use our own intuition to figure out what the right methods we could use to fix it could be. The last one I'll look at will be different ways of measuring leverage points. So as we look across the system of different actors, what are the areas where we could actually make positive interventions? Or where can we have the most bang for our buck? Like, what are the kind of key nodes in this system? We'll do another whoosh transition here. Get ready. Oh, that was good. I'm only joking. So this is a kind of this is a different way of looking at the nodes across the system. So we're looking at two different quantities here. And I've actually made, there's two things in this plot. First of all, I've got no numbers on my axes. And the second thing is I've made up the term for one of those. But, Outlier put me on the stage here, so I can kind of do what I want. So it's fine. So what I've got here is two different ways of measuring the kind of relative importance of the different nodes across the system. So PageRank was the old algorithm that Google used to rank for its Google search. And it kind of measures the influence of the node in a system by looking at all the different links between it. So on the x-axis is our PageRank, and nodes or entities, things with like a higher PageRank are connected to more things, which themselves are connected to more things. So I was just going to present that from the data. But I started looking at the actual points that this PageRank was recommending, and it was actually recommending lots of closed loops. So lots of these kind of closed loops where everything's interconnected to itself, but there's actually not much communication to the outside. So that was quite interesting. So I started thinking about what are some other ways that I can start measuring the relative importance of these. And I kind of came up with this one, which I've called proliferation, but I basically started with every node and started, simulating out from that node. And I wish I had time to actually have a visualization of this in action. But really what I'm talking about is you start with a node and you start saying to yourself, okay, let's go out to all its neighbors, and then let's go out to all their neighbors. And after three steps, how many nodes are you touching? So really all that is to say is that we've got things up at the top right are nodes that have a high relative influence in the system. So these could be areas where we could start thinking about in terms of how we can change behaviors. Now, this first one up here in the top right is a consumption of new clothes. That's literally what this system was built around. But we've got more. We've got things like the discarded clothes, owned clothes, consumer desire, etc. So what this gives us, it gives us automatically a way to actually start analyzing, returning back to our original system, and starting to make some interventions. So we'll return back. Oh, sorry, I forgot to highlight them, but now they're highlighted, so it's great. Nice route. So now we return back to our original system. So we've been able to identify those feedback loops, which is one way of making interventions. And the second way of making interventions, like I just said, was to take these important nodes and start exploring them a little bit more, and start looking at the relationships between them, between the amount of discarded clothes with the lifespan of our garments. And in particular, we could start thinking about, creative solutions that can actually fix some of these. So for example, if we think about the need for affordable clothes, it's really interesting. When I started looking at the system, I've no skin in the game for this, and this isn't something I've actually done with the client. But I started really thinking about, is it like a human need to have affordable clothing? What do we have to do to kind of address some of this stuff to stop some of this fast fashion? So it kind of got me thinking about these things in a slightly different way. I'm probably run pretty much over, but we're nearly at the end. So you're going to get to the book signing and the cocktails even faster. Because like I said, this is kind of a series of initial experiments around these systems. And what we've been able to do is kind of extract out some systems maps straight from Miro boards. We've then been able to automatically analyze these using graph-based methods. So we've been able to find these balancing and reinforcing loops within the data. We've also been able to run some, node algorithms, that's not the word. We've been able to determine what the centrality or the page rank or the stuff I was making up about those nodes were. We found a way of exploring the system in a somewhat intuitive way. So my intention here was to give you guys the link to actually play with this yourself. I was meant to have the presentation version of this and then the actual version of this, but like all the other speakers here, time got in my way. So you'll get this really soon, and I'll provide you the means of contacting me shortly as well. But finally, we went to taking some action. I know I didn't go to it in any great detail here, because it's kind of very much a run-through, and I didn't want the tech to break. But we were able to ingest this kind of Miro board and kind of give some hints to the user about, like, here's this complex system, but here's some points that might be worth you looking at to kind of explore further. And to be honest, like, as I've been running these experiments, everything that's happened has kind of started off another 3 experiments in my mind in that direction. So it's something I'm finding really interesting. And my next kind of step on this project is to start creating kind of more finished-looking materials that bring more elements of storytelling in, so we can not, I'm conscious in this example, we kind of threw a lot of stuff up there very quickly. So something that will kind of hold a client's hand and kind of walk them through why this could be a useful approach of seeing their things. I love the presentation from Jeremy earlier, and I was really taken to the fact that, like, he's not on social media at all, that, like, Outlier were able to, reach out for him and give him that chance. But unfortunately, I'm not like Jeremy at all, so I'm all over all the social media. This is my website on the right-hand side. Go have a look at it. On the left-hand side is a QR code that gives you all the info of me on all the different social channels. But yeah, so joking aside, like, I quit my consulting job in the summer, started off my own business, data and design, because I couldn't really think of another name, and I've been doing some kind of public and private sector work. One thing I never thought about leaving consulting was that I wouldn't be able to use any of my consulting portfolio to show my work, so I've been making work and trying to get work at the same time. So I will plug the out of this, so great. So look, thanks so much for your attention. I know it's been a long day, a fantastic day of presentations, and don't want to keep you that much longer between you and your cocktails. So I'll leave you there. I'm available on these channels or for a cocktail now. Thank you very much.
Actually, I felt very seen when you said all about Tamiro and consultants, how they usually do it, and then they just ignore it. Which, yes, I also did that. I think all consultants did that. I know that is very much a work in progress, but so maybe not, you don't know exactly how to reply, but do you have any feedback on how to better use this type of process for those consultancies that really have no time at all, but like to pretend a bit, think strategically?
We're giving consultants a bad rep here, but as an ex-consultant, I think we could.
Yeah.
It's okay.
Ex-consultant here,
no
too.
Problem. Yeah, no, it's a great question, because I've got into companies and kind of given training. I kind of working in data. I'm from data science background, but then learn design that way. And so I can kind of go in to either kind of data scientists or designers to kind of talk to them. And one of my trainings is kind of talking to designers about data and kind of improving data literacy without trying to frighten them. And I was recently at a consulting company doing this for the designers in there. And the way I framed it is that, like, as designers, they are data set creators. So, like, you might not think yourself, if you're a designer, as someone who's, very data literate or anything like that. But actually, every action you're doing is creating data. If you're populating a Miro board, if you're making a presentation, if you're doing all these different activities. So what I would say in the training was, it's a kind of a mindset when you're doing things on Mural or Miro or any of these other platforms, to be thinking to yourself, what is it I'm putting out here, and how can we, our team, benefit from this? So I was using examples even of things of, like, project retrospectives. That's an activity that's often done in these kind of mapping softwares. But, like, what if we could pull the data from Mural or Miro, from these project retrospectives, get people to kind of rank which ones are most important, and automatically play back those learnings from leadership. So again, these aren't like anything groundbreaking, but in that kind of conversation, I was trying to talk to people and say, start thinking about the data in this way, that everything you're doing, I don't like the old data is oil trope, where we shouldn't be comparing anything to oil now anyway, so that's fine. But, like, the way I think about it, and I can't remember, I'm going to miscredit them now, so I can't remember who said it, but it's like, rather than saying data is everywhere, we should start saying everything is data. And I really like that kind of approach to it, and then thinking about ourselves as data set creators. Sorry, that was a long, rambling answer.
That's okay, that's okay. Any thoughts, reflections? Has anyone, okay. Oh, we have also some from, so Then
Hi there, Rudi here. Thanks very much for a really great talk. My name's Richard from Cambridge, UK. I was wondering if you're thinking of turning the software you've been creating into like an open tool or something like that, and maybe people could drop their own data onto it and get the insights that you're getting.
Yeah, that's the ultimate intention. So it starts off as experiments to start seeing like can we actually do this stuff, and that's kind of where it's at now. It's at MVP stage where I've kind of proved this out. For me, the next step is creating those more final materials so where I can actually go to my clients that I'm working with now and show them, look, if we can do this, here's how it's going to work. So I'm sure it's the same for everybody, that like when you're working on a passion project like this, what you really want is a client involved in some way, not necessarily in building the tool, but actually in the conversation, so you're actually, you're not having to run this into the night as well. But the ultimate intention and the tool for exploration will be up. I won't commit to a time, in the next week or two on my website for sure. I've made that mistake before. But the ultimate intention is this for it to be an open source tool. Because like there's really great software out there, like Loopy is another really fun one that you can actually start like plotting out how things flow in these systems, but it gets kind of crazy after about 5 or 6 different nodes. There's lots of amazing animations, so it starts going mad. So in terms of turning this into a tool, I suppose like I would look at it critically then after a while and start saying like, Kumu is out here, it's an established platform for doing these things and kind of seeing these visualizations. I think there's a little bit extra we can do in terms of this analysis and interactions that can make these less complex. But it'd be my thinking around like, is that worth putting out? Like probably not, like, yeah, so long rambling answer, part 2.
This was impressive. Thank you. My name is Alenka, and I have a question regarding the analysis of the nodes. Because thinking of complexity of, for instance, biological systems, there could be a positive feedback loop to one of the nodes, but maybe like a negative reinforcing one to the next one. So my question is, how far for the nodes you can do this analysis?
Yeah, it's a great question. So one visual metaphor I really love are those Feynman diagrams. So I was originally mechanical engineering and I was kind of into physics, and I used to love Richard Feynman's drawings of these kind of possible paths that things could take into the system. And before this presentation, I actually definitely resembled Charlie from Always Sunny in Philadelphia. One experiment I wanted to do that I didn't show here was plotting all possible paths. So that's another thing you can do. You can take 2 points, follow every potential path that doesn't repeat back on itself, because then you've got infinite paths. You follow every point, and you start adding up the positives and negatives across that. Where I actually stopped with that is that we're talking about here in the system that we were looking at today was a mental model. We were using these as a mental model to understand relationships and between entities, but it's not real. We can't put numbers on these different things. So where I think to respond to your question and what you're talking about and figuring out those positives and negatives, what I would do is apply those to a system where we've got stocks and flows. So this would be like actually tracking using my wolf and deer population before, like actually tracking those populations across the parks. That would be a common one, and that's where we get into modeling systems. But again, there's systems like trying to figure out a complex organization that we may not necessarily be able to model. So hopefully that answered your question.
One last question, and please a short answer.
This is from Nuria Altimir. The insights will be as good as the mirror board contents are. How do you control for that?
Could you repeat the question, please?
Yeah, the insights will be as good as the mirror board contents are. How do you control for that?
The insights will be as good as the mirror board. Oh, sorry, I understand the question now. Sorry, long day. Short answer. Got it.
Okay, you can ramble a bit, but not a lot.
This is a great point. So this is talking about the kind of underlying data that's filling up these systems and how can we actually think about that. So when I kind of spoke about mental models before, that actually can help validate some of the preconceptions or assumptions that we might have about those systems beforehand. So even in the one I was exploring today, I was able to look at some of those nodes and say, oh, I actually don't agree with that. And that's why working on these things collaboratively can be a great thing as well. We're actually working with people and saying, oh, I don't really feel for this, it's that. And in my previous role, when we did work with clients on these kind of systems maps, that was always a really useful process, was actually talking them through and seeing if they agreed with these assumptions or not. That was with the caveat that that was before the whoosh, fun-looking ones existed, so often it was these kind of crazy complex maps that we didn't really want to show to our clients. But the short answer is that it's a nice way of actually validating some of our own assumptions, first of all.